I'm Staff Sergeant Bowler, and today we're going to be looking at some new technology which I think can impact National Guard and Army aviation. A little bit about me. I have an associate degree in auto and diesel technologies. I spent 4 years in the Navy as an aviation electrician on F-14s. I have a BA in history with a history of technology, which I focused on why technology progresses and under what conditions. Vocational degree in electronics. I'm actually 15 November, but I've worked as a mechanic and I've worked as an electrician here at the TASMG in Groton, Connecticut. And I have a website, Prometheus Gone Wild, where I post new technology that is interesting. Helicopters are obsolete, and all their variants. Now, I don't want to lose anyone here. Every time I tell helicopter pilots that helicopters are obsolete, they look at me like I run over the dog twice. And I really do like the Defiant, but it's very complex, and it's going to be a very expensive platform and hard to maintain. The Osprey is obsolete, and all its variants. What makes technology great? Reliability. What does that mean? Low maintenance, ease of maintenance. What makes a machine have low maintenance? Less parts, but more importantly, less metal and medical critical wear parts. This is a key point. For example, here we have a mechanical, purely mechanical watch, we have an electromechanical watch, we have an electronic watch. The mechanical, how many parts does it have? The Rolex has 115 parts. How many of those parts experience wear? All of them. How many are in the Timex? Well, with the battery, you don't need mechanical power storage, so it cuts down to about 30 to 40 parts in the Timex. In the electronic, if it's got a touch screen, there are no mechanical wear parts. You have a board and it degrades. It's only going to break if the components degrade due to vibration and or heat. A better example is internal combustion engine versus turbine. How many internal wear parts does the turbine have compared to the internal combustion engine? Here we're talking about the long block of a V8. 68 mechanical wear parts in a long block. Pistons, bearings, rods. We're talking old school old block. Versus a turbine, it's got 2 bearings. I'm not counting all the oil pumps and all that, but just the basic mechanical parts that can make it run. The Black Hawk, how many parts does it have? 7 drive shafts, 4 gearbox. How many parts does the transmission have? I've never taken one apart, but a lot. Control rods, mixer, mechanical controls to swash plate. All the mechanical parts in the head. 2 turbines, hydraulic actuators, and associated systems. It's a very complex mechanical aircraft. The Osprey, how many parts does it have? There's too many. I could say it's got a drive shaft that goes from one engine all the way to the other side of the aircraft in case it loses an engine. Tactically, it's been a success. It goes 4 times as far, twice as fast. But mechanically, it's been a disaster. It's got a 60% operational readiness rate still, after all this time. What's changed? Lithium-ion batteries. In this chart, we show all the different types of batteries, their power density. Even though this only goes up to 2010, I did a little research. It's pretty much at the same point still, about 220 amp hours. That's watt per kilogram. Here we're going to look at a Tesla D, do a couple power runs down the quarter mile. This is a Tesla D. It's got 2 electric motors. It's all battery. 10.8 quarter mile. It's incredibly fast, and this is a stock car. Here it's going against a Shelby GT 500, 662 horsepower, 631 foot-pounds of torque. Once again, 10.8 quarter mile. It's like clockwork. Obviously, this is a fly-by-wire car. It has no mechanical parts between the throttle and the electric motors. Here it is, a Lamborghini. .8. It beats the Lamborghini by 0.2 seconds. Here's the fastest Tesla, Tesla Roadster versus Bugatti. As you can see, it beats it in just about every category, including range, and it's a lot cheaper. The reason I'm showing you this is to underscore the fact that lithium-ion batteries have gone through a quantum leap in quality, power density, and reliability. And they're cheaper. There's less things to go, there's no exhaust system, there's no fuel system. And this is obviously a purely electric vehicle. Now we're going to go back to aviation. In 2015, I saw a video of the Shadow that the Army is looking to do. It's a vertical takeoff and landing Shadow. I couldn't find that video, but this is the company that the Shadow's patent uses. It's called Latitude Engineering. They're the first ones to put wings on a drone. It's created an entire new category of drone. We call it transitional. It actually takes off and lands vertically, electrically, but then it actually flies with horizontal wings with an internal combustion engine. So you have two different systems, maximizing range and giving it a vertical takeoff and lift ability. Obviously, while it's flying horizontally, it recharges the batteries. Obviously, you can change that under what conditions you want. When you're taking off, you have the motor running. That power can be fed directly into the batteries. So after seeing the Shadow video, in 2015 I actually took out a patent application with this configuration. I wanted to get ahead of this technology for manned aircraft. And what the basic idea is that it's pretty much the same configuration, but you have a turbine or internal combustion engine, a one-way clutch, and then a motor generator with a variable propeller. Now this configuration, what it does is it allows, on vertical takeoff, not only you have a battery pack, but you also have power from the turbine running the generator. So you have two power sources. Now at this point the propellers are spinning, but they don't produce any thrust. And this just shows the you have the battery and you have the generator pushing out power. Obviously, once you're in horizontal flight, you'll be using just the turbine to fly, but it also generates power to recharge the battery. This allows the batteries can be a little smaller or not. You can have actually because it's military, you might want it to have plenty of power in case you lose the turbine. This also allows one turbine as opposed to a standard military, which is 2 turbines, because you already have redundancy. This company's called Volocopter. They're the original to really start trying to make a manned aircraft with the new batteries. What's good about this design, it's got 18 electric motors. So you can literally have 3 completely independent flight systems. Greatly increases safety. Now, it's a helicopter, but it doesn't have a transmission, doesn't have any drive shafts. This is batteries, electric motors. The Chinese have a version called the Yihang that's very similar to this. What's good about this design is it's safe. What's bad about it doesn't have wings, and it's not a hybrid, so its range is very limited. They're looking to use this for in-city transport of people and materials. If you want to go from one side of the city to the next, 100-mile range. But this would be no good for the military, obviously. This is a company called Joby, fixed wing. All the propellers rotate 90 degrees to go from horizontal, vertical flight to horizontal flight. While it's very innovative, I don't really like the design. It's got a lot of moving parts. But because each motor is independent, and you can have multiple independent systems, I'm assuming it's going to be fairly safe. You can lose a motor, it doesn't really matter. You can lose a battery pack, it doesn't really matter. It's beautiful, but obviously it's a civilian aircraft. And like I said, it's got a lot of mechanical parts. Doesn't have a transmission, doesn't have drive shafts, but it has mechanical parts to rotate the motors. Which brings us to Beta Technologies. This is their Aliyah. You can transport 6 people, I think 1,600 pounds total. This sort of falls into what my line, what the military would need. Obviously, this is a civilian version. Now, it's got 4 propellers, but each propeller has 2 electric motors, so it has 2 redundant vertical flight systems. So you can lose a motor, you can lose an entire system, battery pack, controller. You're still going to have vertical flight because you're going to have another entire system. It also has a pusher prop. So that could be a third independent flight system. You could lose 2 vertical flight systems and still do short takeoff or landing or regular landing horizontally like a regular aircraft. Now if you put a turbine behind this electric motor, you'd have pretty much what my design is with a one-way clutch. This way you could run it off the electric motor horizontally, or you could run it off the turbine. Obviously, you'd have to be much bigger. So this is the basic configuration that I think is the future of Army aviation and National Guard aviation. It's got wings, it's got long range, but it's simple. There's very few moving parts. You can have mechanical controls for the horizontal flight systems, flaps. Funny story is you can see the first couple, these pictures, they've got skids on. And I emailed them and I said, look, if you lose your vertical flight systems, how are you going to land horizontally with skids? So a couple weeks after that, they put wheels on it. And the development of this continues. They're actually getting close to FAA approval. They've already sold 170 of them to UPS and another company that wants to fly them to transport people. Because the FAA doesn't have a hybrid aircraft specifications, they're doing helicopter and fixed wing, two separate FAA certifications at the same time. And they've got about a year to go, but they're getting close. So the question is, this is nice, but it's a civilian aircraft. How are we going to build these? We're going to look at some technology to make helicopters, vertical flight, future vertical flight, into battle wagons, something that can really take a hit. To do that, we're going to look at titanium laser sintering, or titanium laser printing. Now, this has been around a while, and with the defense companies have been slow to apply it. So the base technology is you put down 2 thou of titanium oxide, and then you use a laser to melt it all together. As you can see here, they're making 2 parts at one time. That's one of the benefits of a titanium laser sinter. You can make 10, 15 parts at a time. It depends on how big your machine is. And here we see it's putting down another 2 thou of titanium oxide, and it's putting it on a layer. It builds it up layer by layer. This is called additive manufacturing, where you add layers, as opposed to reductive manufacturing, where you take a block of aluminum and you cut out material until you get the part you want. All right, well, you look at this and you go, well, those are very small parts. This is the largest printed titanium piece ever, about 5-6 years ago. The Chinese made it. The Chinese stole all the technology between the F-35, our F-35 fighter. And then they made the J-20. Lockheed was complaining that it was taking them forever to make these parts. The 2 engines go into these holes, so this is a very large piece. Because Lockheed was doing reductive manufacturing. They'd take a block of titanium and they'd cut out. The Chinese printed it. It cost less, took less time, and as you can see, it's massive. I think it's about 6 foot wide, 4 foot tall. This pretty much makes it, it's a frame of the aircraft. So in this respect, we're falling behind. Has titanium been used for support combat aircraft before? Ground support combat? Yeah. The A-10 Warthog, it's got a titanium tub. In my mind, this is what we want to do with future VTOL aircraft with the Army and the Guard. We're making a battle wagon. The Black Hawk, as good as it's been, is not robust the same way this is. And the Warthog doesn't land like the Black Hawk does, but the Chinook does. We need to make a more robust VTOL aircraft that can land in enemy territory, get shot up, and just take off. The Warthog is a perfect example of this. Now, if we were to make a fixed-wing VTOL aircraft in the configuration I've outlined here, what's also another benefit? In-flight refueling, loitering. Right now, we don't really have in-flight refueling. Special Forces does, but they carry a ridiculous amount of fuel, and they have in-flight refueling. It's still not enough. Helicopters just aren't long range. It's one of the reasons that the Osprey has been sort of the go-to for Special Forces. They need that range, even though the complexity and the maintenance requirements of the Osprey is a nightmare. Now we talked about titanium as for the frame. Now pieces can be created and bolted together. You're not going to make an entire aircraft in one shot. Now bolting helicopters together has been done. The Sikorsky Black Hawk, we bolt the tail on and the pylon on, so it's not that crazy of a thought. But having pieces that are printed up and bolted together allows for ease of battle damage. You just pop parts off and put new parts back on. And if you're looking to upgrade an aircraft that you've had around for a couple decades with new technology, it's not that hard. You just take off the old sections and put in the new sections and bolt them on. I also see that in theater, you could have ceramic plate on the outside and Kevlar on the inside. So you have multi-plate, multiple layers of protection. Ceramic, titanium, Kevlar. That type of aircraft would be able to land anywhere and take a hit. What we're going to look now is, this is a new type of glass. Aluminum oxynitride. They're going to shoot a 50 caliber round through it and some ballistic glass. Here's almost 3.7 inches of a ballistic glass laminate. And as you can see, the 50 cal round goes pretty much right through it. And here's 1.6 inches of Alon. I guess that's their trade name. I mean, that's just phenomenal. Granted, it's going to add weight, but on the Black Hawk, we have plexiglass on the front of the nose still. If you don't take it off just right, it cracks and it breaks. It's very sensitive. I understand that you have to take in consideration the ability of aircraft to transport things, but also I'm thinking the Army needs to look more at survivability. This is phenomenal technology. All right. Next, we're going to look at carbon fiber. Now, I don't think carbon fiber is good for military helicopter because even though it's lightweight, most civilian aircraft are made out of it now, it really can't take a hit. But there is one thing carbon fiber is good for, and that's hard landings and crashes. We're going to take a look at that. As carbon fiber breaks, it absorbs energy, unlike steel or aluminum, which bends and absorbs. But as each piece of the carbon fiber snaps, it absorbs a great deal of energy because it's not only incredibly brittle, but it's incredibly strong. This could even be used on today's helicopters for hard landings or crash landings. I'm not sure why it hasn't been applied to that. All right, where are we at? Army versus Air Force. Before the Vietnam War, the Air Force and the Army generals got together, and there was a dividing line between Army aviation and Air Force aviation. Air Force is doing fixed wing, Army is doing rotors. And that's good until now, with the new technology, you can have fixed wing aircraft that take off and land vertically. At this point, we got to change where we draw the line. And in my mind, it's more about role. The Marines versus the Navy, they have this going on. The Marines focus on ground support. Harriers are ground support. It's not about air superiority. The Marines don't have any large aircraft because they're not there for supply. The Navy's there for the supply. We sort of have to go, I think, to the Air Force and work this out. How, obviously, the Army and the National Guard would go over a certain size, and it would be focused on ground support. This would allow the Air Force to actually focus on large-scale supply, air superior, air control, and Army aviation would focus on theater, movement of troops, and their equipment. The A-10 would be made redundant to Army aviation. If the A-10 goes away, who gets that money? I know I read an article a while back that says the A-10 needs all new wings. So it's at the point where they need something new. And I hate to say it, the Air Force is a little ahead of us in this. They've got this program called Agility Prime, and they're helping companies like Beta Technologies and Joby get certification. They want to help these companies push forward because the Air Force wants to buy their stuff. The Air Force doesn't like the Osprey. They have the Osprey because they have to rescue their pilots, but they don't like it. So if we don't get there first, they're already there. In conclusion, where would this leave Army aviation? Aircraft that are fast, robust, and can land anywhere. Safer aircraft with less critical wear parts and multiple redundant flight systems. Army aviation can support more aircraft with less maintenance personnel. In-flight refueling for extended range, including loitering. Easy to upgrade, easy to repair, just unbolt and change parts. A family of aircraft, attack, troop transport, and equipment transport with interchangeable electric motors and turbines. And my idea is to have the same gun system on every Army aircraft, attack, to give it support and commonality. That doesn't mean it has to be made by the same people, but the specifications have to be the same. The turbines, the electric motors, you can have different companies make them as long as you can drop them into one of these aircraft. And I just wanted to end showing Beta Technologies aircraft for the final time. Because this, in my mind, is the very simple civilian version of what I'm trying to put forward as a platform for the Army and National Guard. Now I know the question is, why is Staff Sergeant Buller reaching out with this? Why isn't a Sikorsky rep, an engineering Sikorsky rep, or Bell or Boeing, why aren't they reaching out? Well, the fact of the matter is, we know Sikorsky, the Army is going to buy the Defiant, and they might buy the Valor also. And the Air Force and the Marines probably will buy the Valor. They've been working on these systems for a long time. Those companies do not want to just walk away from them, even if they are obsolete. I think they're running scared a little bit. Every one of these companies has hundreds of sheet metal people, hundreds of machinists. They need to. Beta Technologies has less than 100 people. They outsourced the body. They bought the electric motors. If they want to stick a turbine in this, they buy the turbine. They assemble. They design and they assemble. They don't have hundreds of machinists. They don't build transmissions. It's much simpler design. I think that's the reason Bell, Sikorsky, and even Airbus are looking down on this new electric aircraft market. I think they're scared. Much like GM killed the electric car at the very beginning in the 90s. They ran them all through they mulched them all up. I think they're scared that they're going to lose their market share. And I think this is very foolish. What Sikorsky needs to do is to buy Beta and incorporate what they're doing into it and sell it to the Army. But I don't think that's going to happen, at least not soon. So I think it's up to the Army and the Guard to really look at what's in their best interest and see that this is the future and push it forward. Once again, I'm Staff Sergeant Buller. I work at the TASM-G in Groton, Connecticut, rebuilding Black Hawk helicopters. And if you'd like to get in contact with me, my phone number is 860-212-6367. Thank you.